In this video, we're going to talk about how inheritance works in C++. So we'll start off with some already defined base class, and this could be any class that we've created in C++. In our example, we'll have a parent class that'll have a name and two methods, and we call the methods method 1 and method 2. So my derived class is going to be based off of parent, and I'm going to call it child. So the child is going to have an age member, and it's going to define two methods, an overridden method 1 and then a new method, method 3. Notice that child doesn't define method 2. If we have some base class, and in this case it's parent, when we derive a class from parent, the members of parent are now part of the child class. And so we're adding additional data members, but those original data members are there. Now with method 1, we've overridden method 1, although we'll see in a later video the way C++ works, there's actually a copy of both methods in the child class. Child has a method 2, but it's the parent's method 2, and then child adds method 3. So there's an overridden method, there's a method that it's inheriting from the parent, and then there's a new method that it's defining itself. So now let's take a look at the code. Again, I'm going to put using namespace standard at the top just so I don't have to keep using the scope resolution operator. And then I define class parent. It has a protected member, meaning it's public to any descendant classes of parent, but it's private to any other class. So in my constructor, there's a few things that I want to point out. The first is I'm passing a string in, but I'm passing it as a constant reference because number one, I don't need a copy of it. And number two, I don't want it to change. I also have a default value, which would be person X. If no parameter is passed, then that parent object would get the name person X. My constructor is going to use an initializer to initialize the name field with whatever n was passed in as a parameter, and then I print out a message indicating that the constructor is running and what the name is. Methods 1 and 2 are simply just displaying output saying that this is the parent class and this is what method is called. So I instantiate a new object, and again in C++, we can instantiate actual object variables, not reference variables, but an actual object variable. And so that's what I'm doing here. I have a parent word cleaver, and then I'll call the two methods before I exit the program. So let's see how this part works. And again, we haven't used inheritance yet. And you can see when we instantiate the parent object, the constructor executes, and then here you can see both parent class methods being called. So now let's write our derived class. And we're going to call that child, and it's going to inherit from parent. So the child class is going to have a private member, and it'll be an integer for the age. And then it's going to have a constructor. The constructor is going to take in a constant string reference and also a constant integer reference. And we'll set the default as 0 for the integer and baby for the name. Now I'm going to use an initializer here just as I did above. However, here I can call the parent constructor to initialize the parent data members. I already have code to do that when this constructor gets called. So I'll just call that constructor within here to take care of the base class parts of the derived class. And then I'll also use an initializer to initialize age. Then for my code, I'm actually just going to copy what we had in the parent and change that to child. And let me add a little bit more here since we have an age. And I think that looks good. So now I have my derived class through inheritance. Now let's create a child object. And I should say object there. And they should be capital. So I'll say child object, beaver cleaver. And then I'm actually going to do the same thing I did for the parent with the child, except I'm going to be using the child object. So I'll just change those. And then remember the child object has method 3. And I think it looks like I forgot to implement my methods. Just like I did with a lot of things here, I'm going to do the same thing I did with parent. So I'll have method 1 and 3, and then I'll make sure to change this to child. So that should clear up the error now that these methods are defined. So if I compile and run, you can see that I instantiate a parent, I instantiate a child, which, because child is a derived object of parent, child calls the parent constructor. Then you can see that when I call the parent object methods, everything behaves as you would expect. When I call the child methods, for the child, it doesn't implement method 2, so it actually calls the parent method 2 because it gets that through inheritance. So we'll see some more examples later in this module of inheritance, but I wanted to give you a quick overview of just how it works, how the mechanics of it work in C++, because there's some differences with how this works versus with Java. So hopefully that makes sense to you. And if not, we will see some additional examples later in this module.